All right, we're going to go ahead and do a little review of the 2-5 linear inequalities. We have a practice worksheet we're looking at. We weren't, no one asked about 2, but wouldn't this be that vertical line with an undefined slope, guys? Okay, so I'm going to remind you that it's a vertical line and the slope is undefined. Like, the more you write that down, the more you think about it, the better it is. Don't forget that you need to shade these dashed and solid lines. So we're going to jump in here to number 3. It's really important that we follow the directions. We are graphing using slope-intercept form. So to get full credit, you would want to solve this for y equals mx plus b. So there's points for that and then points for the graph. Okay, so to solve this for y, I'm going to subtract the 3x from both sides. I'm left with 6y is greater than, and it could be 9 minus 3x or negative 3x plus 9. That's what I'm choosing. And then I'm going to divide each piece individually by 6, and it leaves myself much room here. So my final equation is y is greater than, reduce that fraction to negative 1/2 x, reduce that to a positive 3/2. So not the prettiest equation. Now, this is my starting point. So my slope is negative 1/2. My y-intercept is 3/2, which is 1.5. Okay, so this is what really throws people off, but you gotta work with it. Go to 1.5 on the y-axis. This was a good pick. And when you go to do your slope, when I say -1, I'm going to go down -1. That puts me at 1/2. And then I'm going to go right 2. So if you ever have one of those odd starting areas where you're not on a nice integer, just remember when you go to do the slope, just put yourself, that many units down in the same spot. I can go down 1 unit again and then right 2. And then would this be dashed or solid? I almost forgot. Would be dashed or solid? It's going to be dashed. Okay, so remind myself of that. And then we have to determine where to shade. Now, we want to look right here when we determine where to shade, because remember, if we multiply or divide by negative, we flip the sign. So y is greater than this. That would be going up this axis. Y is greater than the line. Now, if you don't like that method, that's okay. You could also use a test point. The easiest test point is 0, 0. So I take my 0, I plug it in. Is 0 greater than, that'd be 0. Is 0 greater than 1.5? No. So if 0, 0 doesn't work, then everything on the other side works. Okay, definitely not enough room for me to show all that work. All right, now the next set says use intercepts. And notice it says give answers as ordered pairs. So I think if we sort of start ourselves with the idea that I have an x-intercept and I put my ordered pair right here, I'm not going to forget. I have a y-intercept and I put my ordered pair, I'm not going to forget. Okay, let's do the x-intercept. It's on the x-axis and the y value is always 0. So I take that 0, I plug it in. It's going to be negative 2x plus 0 is less than negative 6. When I go to divide by negative 2, I get x is greater than 3. Okay, so again, I put the 0 in, it wiped out the 3y, and it left me negative 2x is less than negative 6. When I go to plot that point 0, I can leave it there and not go any further, but if I want to think about the shading, x is greater than 3, I would shade this way, and that's going to help me later. So I'm just looking at the x value. Okay, the y-intercept is on the y-axis. The x value is 0 because we want to find y. So if I put 0 in, negative 2 times 0 is 0. I'm left with 3y is less than negative 6. Now, I'm not flipping my sign because I didn't divide by negative. I just divided by 3. So my y value is negative 2. So plot that point. And then it says y is less than negative 2, which would mean I would go down the y-axis. This one is also a dashed line. And if I look at my x individually, my y individually, do you see that both of them say to shade over here? So this would be my shaded region. Okay, now, you can't look at this and say, oh, the inequality is less than negative 6. That's a whole different ball game, because in order to use the inequality symbol, we have to have y equals the slope, the line. So if you don't like the individual test, then use your test point of 0, 0, if that makes you more comfortable. That'd be negative 2 times 0 plus 3 times 0. Is 0 less than negative 6? No. So 0, 0 doesn't work. Nothing works here. It must be the other half. Okay. The only time you can't use 0, 0 is if it is on your line. Okay. All right. So the other one you asked about was number 9. So go ahead, flip over to number 9, give it a quick read. Okay, a really exciting word problem, right? So it said you've earned $50 from tutoring and you want to go to this fair. So if you have $50, I want you to think about this. How much money can you spend? That's what you have. You have $50 from tutoring. That's all the cash you have. You can spend $50 or more, $50 or less. $50 or less. So what you spend has to be less than or equal to 50. A lot of us see 50, we want to say it's equal to, but I don't have to spend all 50, right? $50 or less. Okay, now each ride is $2.50 and each game is $2. So there's no entrance fee. It's $2.50 for every game. $2.50 for every ride, $2 for every game. And here it is, guys. Here's the ticket. How many of each can you do? That tells me what I'm looking for. And what I'm looking for is my unknown. How many of each can I do? So what are my variables? I know how much the rides cost, but do I know how many I can go on? No, if I go on 10 rides, wouldn't that be $25, $250 times 10? So I'm going to let X, and normally I would use R for rides, but I have to graph it. So I'm going to stick with X and Y. X is the number of rides. You have to quantify your numbers. Number of rides. And Y is the number of games. Now, just to keep myself organized, each ride is $2.50. Each game is $2. Okay, now it says write an inequality for the number of rides and games. Guys, you got to think it's cost times quantity. So I'm going to spend $2.50 times X. That's $2.50 times the quantity of games. This $2.50X is all the money I spend on rides. Okay? I would add to it $2 times the number of games. 2y is $2 times the number of games, but that's total money spent on games. So all my money here, we have $50, and you told me what I spend has to be less than or equal to 50. Now, my inequality is in standard form. If I wanted it in slope-intercept form, I would have to solve for y. But it's really hard sometimes to graph a word problem, because if we're counting by 5s or 10s and my slope is 3/5, that's really hard to make accurate. So, and sometimes our x and our y axis, we don't count by the same number. So it is actually more accurate to use your x and y intercept. So give the intercepts as ordered pairs. So in order to solve this, let's find our x-intercept, do that math, and we'll find our y-intercept. Okay, this helps me, guys. My x-intercept, I'm looking for x when y is 0. I'm looking for y when x is 0. Take your 0, plug it in. 250 times x. If I put 0 in here, doesn't that cancel it out? If I put 250, if I put 0 in for y, I get 0. So it'd be 250 is less than or equal to 50. Divide both sides by 250. And what do we get? We should get, well, I want to make sure my brain is seeing this right. Yeah, we should get 20. So what's that mean? That's 20 rides, 0 games. So if I want to only do rides, I can do 20 rides. That's my maximum. So I'm going to write that down. X has to be less than or equal to 20. Okay, so that's going to help me graph. Now, find your y-intercept. Plug the 0 in. That's going to wipe that out. And I'm left with 2y is less than or equal to 50. divide both sides by 2, y is less than or equal to 25. Okay, so that is my y-intercept. What's that mean? It means I ride 0 rides and I play 25 games or less. Okay, so I have some hints for you to help you with graph. Use your proper techniques like labels, even intervals, only in the first quadrant, and don't forget to shade. So here's my information. And down here, I am going to have to label this. So I'm going to have to squeeze this in. This is number of rides. This is number of games. Okay. If I didn't tell you to count by 2s, you would want to count it out. So 2, and then each block is 2. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. So I'm going to show that 2, 4, 6, 8. I'm just trying to save myself some time. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. Okay. So there's my labels. I've got my label on my graph. I've got even intervals showing. And then I've got my x-intercept. And if you remember, it was 20, 0. So put a point there, 20, 0. And if I want to think about the shading, the x was less than or equal to 20. So I know I'm going to shade to the left of that point. Okay. My y-intercept was 0, 25. I know this, maybe I should have zoomed out. My y-intercept was 0, 25. So 22, 24, it's going to be right here. And it also was less than or equal to. So I'm going to shade going down. All right, so do the best you can to make a straight line. Got my handy dandy ruler. It's going to be solid because we could spend exactly $50. Okay, and notice that my line does not continue on. Notice I went point to point, and there's a reason for that. You're going to lose points if you don't do it this way. If you go past here, you're telling me you have negative rides, and if your line goes past the first quadrant down here, that would be going down into negative games. So anytime you're talking about a word problem, and we're not talking about having money, you know, that you have negative money, we're looking only in the first quadrant. And then the shading would stay in the first quadrant because the minimum I could have is 0, 0, meaning I spend no money. Okay. So if you wanted to pick, anything in the shaded region on one of the axes or on the line, that would be something that suffices how many rides and how many games you can do under $50. Now, does it make sense to have a half or a third of something? We should have all whole numbers, right? 0, 1, 2, 3. So now you could be asked questions, and I know it doesn't ask you this here, but I could say, if you rode five rides, how many games could you do? So if I asked you about 5 rides, you would plug that in and say, well, 250 times 5 plus 2y has to be less than or equal to 50. All right, so 250 times 5 should be 1250 plus 2y is less than or equal to 50. So I'm asking, if you rode 5 rides, what would happen? And I could estimate, guys, 5 rides would be right here. I could do any number of these games. I would subtract, so I would get 2y is less than or equal to, I'm trying to double check my math, 3750. Divide both sides by 2. Now I get this odd number. I get y is less than or equal to 18.75. So I want you to think about the greater meaning of this. That 18.75, normally we would round up to 19, wouldn't we? Because 18.75. But notice it says y has to be less than or equal to that. I can't play 18.75 games. So what's the maximum number of games I can play? 18. So I could play 18 games or less. And a lot of people forget about that or less, because we're so worried about how many games. As long as I spend less than $50, if I ride 5 rides, I can do 18 games or less. And that's going to be something that people lose points on because they just write 18. All right, I think I'm out of my